Strong and weak acids and bases. This has to do with how much they ionize. It's related to strong and weak electrolytes. An electrolyte is a solution that will conduct electricity in water. A strong electrolyte dissolves completely into ions. A weak electrolyte only dissolves a little bit into ions. Hydrochloric acid, hydrofluoric acid look very similar, right? HCl, HF, fluorine and chlorine are right next to each other in the same group in the periodic table. These acids should behave the same. But there's a really important difference. HCl is considered a strong acid because when you put it into water, it completely comes apart into hydrogen ions and chloride ions. Hydrofluoric acid is a weak acid. You only get a few ions. This has nothing to do with how concentrated or how dangerous an acid is or how much damage it would cause. It's just how much does it ionize. So here is an illustration of a strong acid in water. HCl, we put this into water. These hydrogen ions are released and they immediately jump onto a water molecule to form a hydronium ion because they're too small to be out by themselves. And then we have the chloride ions hanging around. We do not see any HCl molecules in here. Here with the space-filling models, this comes in here. The little the white ball goes and hops onto a water molecule. So these now have 3 white balls, and then we see the chlorides hanging around. We don't see any of these that are together in solution. That's what a strong acid does. It completely comes apart. If you have a 1 molar HCl solution, that means you have 1 mole of HCl per liter of solution. Then the hydronium ion concentration will be 1.0 moles per liter. When we put anything, a formula inside of brackets, that means the molar concentration of whatever that is. So X in brackets means molar concentration of X. H3O plus in brackets means molar concentration of H3O plus. So that is 1 molar. For every 1 mole of HCl, you produce 1 mole of hydronium ions. This is a single arrow. It goes completely. It's not an equilibrium. It doesn't go back and forth. Any questions? Strong acids are strong electrolytes. So here's a setup with a light bulb and a wire going into a beaker of pure water, and these electrodes are not touching, but this electrode is connected to a wire that's coming out here, and if we follow these wires off the screen, they're plugged into the wall. It's plugged into the wall. There's no off switch, but this light bulb is not going on because pure water does not conduct electricity. Now, why is it dangerous to be messing around with electrical equipment when you're standing in puddles of water? That's not pure water. Okay, even tap water has things dissolved in it, and that can be enough to conduct electricity and give you a nasty shock, if not actually kill you. But this is pure water, deionized water, no ions at all. We throw some hydrochloric acid in there, it dissolves completely into ions, it ionizes, and those ions can carry the electric charge and the light bulb goes on. There are 6 strong acids. Hydrochloric acid, hydrobromic acid, hydroiodic acid. See, fluorine is the little sister of that group, and so hydrofluoric acid isn't strong, but the other 3 are. And then we have nitric acid, perchloric acid, and sulfuric acid. This is a diprotic acid, right? It's got 2 H's in the front here. Monoprotic, 1 ionizable hydrogen. Diprotic has 2. And we mentioned earlier, phosphoric acid has 3 ionizable hydrogens. So the way you tell whether it's a strong acid or a weak acid is you memorize the 6 strong acids, and if it's not one of those, it's a weak acid. Weak acids don't ionize completely. They ionize a little bit. So hydrofluoric acid is weak. You put it in water, and it gives up Some of them give up their hydrogen ions and some don't. And so we get some hydronium, we get some fluoride, but this is partial ionization. We do have an equilibrium going here. There are significant amounts of the reactants present. So weak acids are like parents that are maybe a little too attached to their children, and even when it's appropriate, they're unwilling to give up the child to a babysitter. Well, no, I'll just take the baby into the bathroom with me. I don't want to pass it off to someone. It would be okay. Pictures, you put HF into water, you get some fluoride ions and some hydronium ions, but you also have a lot of the intact molecule just floating around. Pictures, here's the molecule. We put it into water. Some of them come apart, many of them do not. That's a weak acid. It does not ionize completely. Weak acids are weak electrolytes. So here we have the pure water with the light bulb again. We put the same amount of HF in as we put HCl in. We only get a weak glow in the light bulb because it doesn't make as many ions. A lot of this is HF, the molecule, which is not going to help conduct electricity. These are some common weak acids. There's a lot more. There's 6 strong acids, everything else is a weak acid. So looking at these pictures, which one is showing a weak acid? A, B, or C? C. It takes a while to realize what on earth are we looking at here, right? So here we have, these are hydronium ions. Hydronium ions are represented as 3 white balls and a red ball. And then we've got iodide here. In this one, we've got hydronium ions and nitrate ions. And over here, we've got hydronium ions, and we've got CHO2 minus ions, but we also have the intact acid. So this is the weak acid. This is a picture of a strong acid, and this is a strong acid. What is the hydronium ion concentration in each solution? Well, first we have to look at this. This is an acid, right? It starts with H. Is it a strong acid or a weak acid? Strong acids were HCl, HF, HBr, H2SO4, HClO4, and HNO3. This is a weak acid. Weak acid ionizes partially. So when we put this into water, we have an equilibrium here. And we're going to have CHO2 minus plus H3O plus. But not all of this is going to react with the water, only some of it. Now, with the amount of information given here, we can't say exactly what the concentration of the hydronium ion is. All we can say is it's less than 0.5. We have 0.5 moles per liter of the weak acid. Some of it produces hydronium ion, but not all of it. So all we can say about the weak acid is that the hydronium ion concentration is less than 0.5 molar. Some of it ionizes, but not all of it. How about HI? Is that a strong acid or a weak acid? That's a strong acid. It's in the table. So we put that in water. It ionizes completely. Single arrow. So we're going to get H3O plus and I minus. All of it is going to go to the products. We're not going to have any HI left. 1 mole of HI produces 1 mole of hydronium ions. If we have 1.25 moles per liter of this, it will all form that. And so the hydronium ion concentration is the same as the acid concentration. What about HF? Is this a weak acid or a strong acid? This is a weak acid. It's not one of the 6 strong acids. It does donate protons. It does act as an acid. But it only does it partially. Some, in fact, a lot of the HF stays together. So if we have 0.75 moles of HF per liter of solution, and only some of it forms hydronium ions, then the concentration of hydronium ion must be less than 0.75. And again, putting H3O plus in brackets, that's the chemist abbreviation for the molarity of that. So the molarity of that is going to be less than 0.75. Any questions? Now with strong acids, strong bases, again, a strong base dissociates completely. These end up being soluble metal hydroxides. And so these are the most common ones: lithium, sodium, potassium, strontium, calcium, and barium hydroxides. Many of the other hydroxides are not soluble in water, and so they aren't strong bases because they won't dissociate completely. They really just don't dissolve at all. So picture sodium hydroxide comes apart. We don't see any of the blue, red, white molecules or formula units in there. Excuse me. What's a weak base? Well, it's like a weak acid. It doesn't ionize completely. The weak bases are generally not going to be metal hydroxides. They're going to be things like ammonia. Ammonia is really the only weak base we're going to talk about in this class. The generic, we could use B for weak base. A base accepts a proton, so it's going to accept a proton from water and become BH plus, and then we'll have some hydroxide ion being formed. But this is an equilibrium. It's not going to go to completion. So ammonia is one of these weak bases. So some of the ammonia will accept a hydrogen ion and become ammonium, but some of it will not. So when we put ammonia in water, we see a lot of intact ammonia molecules and only some ions because it only ionizes partially. There are a lot of weak bases. Just like with the acid, there's a few strong ones and a lot of weak ones. With the bases, there's a few strong ones and a lot of weak ones. Most of the weak ones are actually organic amines, like pyridine and methylamine. Bicarbonate ion, though, is a weak base. And that's what's in baking soda. So that's why when we spill acids in the lab, we have baking soda, and we just sprinkle it on there, and it makes carbon dioxide bubbles, and it neutralizes it, and then we can clean it up and not worry about it. So if we're looking at bases, and I'm trying to figure out what's the hydroxide ion concentration. So there's barium hydroxide. Is that going to be a strong base or a weak base? Any of the metal hydroxides that we're going to ask you about are going to be strong bases. Okay? I'm not going to trick you and give you something that's not soluble. So barium hydroxide is a strong base. What that means is when we put this in, you got to choose the writing tool first. When we put this in water, it's going to ionize completely. Well, actually, I don't need the water. Let's just do it this way. This is going to come apart in water and form a barium ion and how many hydroxide ions? 2. This is BaOH2. There's 2 hydroxide ions. So for every, what am I pointing at? For every 1 mole of this, we get 2 moles of hydroxide. So we can think of it this way, 0.055 moles of barium hydroxide per liter of solution. And this is asking, what's the concentration of hydroxide ion? Well, I want moles of hydroxide per liter. I need moles of barium hydroxide to go away. So looking at this equation here, I get 2 moles of hydroxide for every 1 mole of barium hydroxide. So this is going to be, oh good grief, 0.055 times 2. 0.11 moles per liter of hydroxide ion, which is the same as 0.11 capital M. Any questions? We could write water in there. It's just a little more difficult. Okay, C5H5N. Is it a metal hydroxide? No. So we can pretty much say it's not a strong base. Is it an acid? No, it doesn't start with H. It must be a weak base then. So a weak base, when we put this into water, it's going to ionize partially. So C5H5N is going to pick up a hydrogen ion, and then we're going to have OH minus left. This is the base, the water's acting as the acid. Here we get the conjugate acid and the conjugate base. This hydroxide ion concentration, is it greater than, the same as, or less than this concentration? This is an equilibrium. It does not go all the way towards the products. Right? It's a weak base, so only some of this reacts and some of it doesn't. So all we can say is that the hydroxide ion concentration is less. In Chem 2, oops, I didn't want an equal sign. In Chem 2, you'll learn more than you wanted to know about the concentration with the weak bases and weak acids. I'm teaching that class right now. And yeah, it's fun, but some of the students, their just heads are about to explode. Sodium hydroxide, strong base, weak base? Strong base. So we're just going to say that metal hydroxides are strong bases. Anything else that's a base is a weak base. So for a strong base, this one, we did all this work and thinking. Let's just look at this. When this comes apart, how many hydroxides do you get for each sodium hydroxide molecule? Just 1. So when this comes apart, it forms sodium ions and hydroxide ions, right? So then what's the hydroxide ion concentration? Just 0.45. Any questions? So we'll call it a day there. If you are a Tuesday lab person and you didn't come to lab on Tuesday, you really should come today. It's our last experiment this week.
This is the last lap?
Last lab. Pardon me?
12, 13, and 15, right? Tuesday?
And part of 11.
Part of 11?
I
You know where we left off on 11?
Yeah, I put an announcement on Blackboard. I think it was 11.4 is where it starts. It's Thursday morning at 7 a.m.
Okay.
during finals week.
And it covers all of the chapters? Okay.
Whole semester.
Does it matter what side we send it on?
Yes, it does. So I think it's the 7th, isn't it? Yeah, it's the 7th. Yes. Right there.